What the hell?
Yo guys, let's play some catch.
That's a great idea. Isn't the ball supposed to move in catch?
Sad face. Why isn't the ball moving?
Well, obviously it's because of Newton's first law.
Newton's first law states that an object experiencing no net force will remain at rest or at constant velocity. In this scenario, the force of gravity on the ball is balanced by the upward, normal force exerted by the ground, so there is no net force. Therefore, according to Newton's first law, the ball experiences no acceleration and remains in its initial state, at rest.
Damn, that was a pretty fun game of catch. Except when Sarah did that physics explanation thing. Unamused face.
Angry face.
Sigh. Shaking my head.
Alright guys, let's get this game started already. My Puffle ain't getting any younger.
Alright, bring it. HMM. I wonder what makes objects like soccer balls accelerate.
Well, obviously it's because of Newton's second law.
This is a free body diagram of the ball. The force going downwards is the force of gravity, while the force going upwards is the normal force. There is a force facing left, which is the applied force from the kick of the ball, which overpowers the force going right, which is the force of friction. As a result, we have an unbalanced force on the ball going left. Newton's second law, which states that force is equivalent to mass times acceleration, means that the acceleration of the ball is directly proportional to the unbalanced force of the ball and its mass. In the case of the ball, acceleration is greater than 0, which resulted in moving from rest.
In this example, we have a force A acting upon a soccer ball with a mass of 5 kilograms. This force has a magnitude of 5 newtons. The arrow above the F simply tells us that the force is being applied in some direction. To demonstrate our understanding of Newton's second law, let's calculate the net acceleration. From the previous slide, we know that the force acting upon an object is equal to its mass times acceleration. Rearranging to solve for acceleration, we can write acceleration equals to force over mass. Finally, plugging in our values, we find that the acceleration is 1 meter per second squared. This means that the velocity of the ball increases by 1 meter per second every second, hence seconds squared. We can also determine the units of acceleration by realizing that 1 newton is equal to a kilogram meter per second squared. And since we are dividing newtons by kilograms, our final unit should be meters per second squared.
Now you know about Newton's first and second laws. Thanks for watching.